Good day. This is my play tool for my cat, and I want to demonstrate something with it. I can tap it like this, or I could press and then release, and press and then release. Notice how it's like bend in when I'm pressing like this, and then bends out. Well, it's a little bit old now, but the point is I could tap it on a point here, or I could press it on a point here. So if I give back this to the cat, we can continue with the point I want to make. Yeah, point I want to make. Literally a point I want to make. So we could think about my finger pressing on that ball as being a point. And then I'm pressing my finger here. Or I could tap it, or I could press it gently and then release. Press it gently and release. And we can. This is something that happens over time, and we can represent it graphically. So if this is time, and this is my action when I tapping on the thing. But what I want to say is like I could apply different pressure on the ball. So this here is a pressure, or you can also call it apply a force on the ball. Or you could think about it that the ball is receiving a tension. So I'm not going to give it some specific name here. I'm just going to say that there is some kind of value here. Yeah. So if we start here at time 0, don't do anything, and then after a little while, I've tapped the ball. So I give it a hit like this, and then you have like at this time point here, I hit the ball, and that's the pressure or the tension or the force the ball feels. Then I do nothing, and then after a little bit more time, I do the same. So we get like dots like this, and we can see this as like spikes. We can think about it as spikes over time, and every spike represent when I tap the ball. If we go back to when I was like pressing on the ball, we could have the same thing here. Time, value. But now it's not spikes. I'm applying a soft pressure to the ball, and it comes to a maximum, and then I release the pressure. It comes to a minimum, and then I go on like this. So the point I want to make, yeah. The point I want to make about the point is that this is time, okay, and this is how much pressure, or tension, or force I apply to the point. So this curve we see here is just a representation of the time, how much pressure that particular point is receiving. So if I want to know, for instance, here is 12 o'clock, and this is 12:01. If I want to know exactly what pressure it was 30 seconds past 12, I just go in here where it says 30 seconds, and then I could just read off, and then I know that pressure at that time point was at its maximum. Or I could go in another time point. This looks like about 10 seconds, and here the pressure was at the minimum. Okay. Now that's a basic idea that you can represent. The idea is that the value can change in this point, and over time it takes the shape of a curve. It can be spikes like this, or it can be like a wave like this, or it can be anything else. I could take the ball, have no pressure, and then very fast I apply hard pressure, and then I release. And then very fast I apply hard pressure, and then I release. What we get then, instead of spikes, we get like squares like this. Okay. So you see what's happening here. So this means I don't touch the ball, and then I touch the ball, and then I release, and then I touch the ball again, and then I release, and then I touch the ball. So I apply a pressure over a short time, constant pressure, and then I release it. Apply a constant pressure over a short time, and then I release it. Here I go as smoothly, and this means that this shape here, it doesn't have to be wave, or it doesn't have to be squares. I could like suddenly press and then slowly release, suddenly press and slowly release. What we will get then is something that looks like this. Or I could reverse it. I could apply slowly and then release. Apply slowly and release. Then we get the opposite. Slowly increasing, suddenly goes down to, slowly increasing, go down to 0. Slowly increasing, go down to 0. So you get the idea that you can basically, from this point here, you could create like any kind of curve in one point over time. Now, if you have seen my video Physics for Dummies, where I talk about field particles and waves, what I mentioned in that video was that if you have a line like this, a wave can be represented on a line like this. This is a wave, and what I said is that this wave I was showing in the demonstration, you should not think about it as like a wave, but as values along the line. So it's values along the line. That's what it is. So, and these are positions in one dimension, positions. So here is starting position, a little bit further away, and long place away. And all these are positions. So what we can say here is like we can have positions here, positions, and then we put in a lot of fixed values here. Okay. So we're not talking about time now. We just have a line where we put in a lot of values. And what values do we put in? Well, we could have values like this, or but I'm going to, you can have any values, but I'm going to have a wave because I want to come to a point at the end. So we have values like this. So this is not time anymore, but we still have value here, and we have position. So if I want to know what's the value over here, let's say this is position x here, x. What's the value of x here? I go in this graph and then I just read it off here. Value somewhere there. Okay? So this is fixed. Now, if you think about this point here, this has a specific value here now, but it's not time dependent. We could make this point time dependent, like this. And we could make that point change value over time, like a wave. So we could, this point here, that value can go up and down, up and down, up and down, up and down. And if we can do this with all of the values here. So if we think about instead of, so we have this space here with all the lines, okay? And they have values. Then what we can do is we could think about this as a time point, but instead of having one dimension, now we have two dimensions, where we have let's see, so we don't mix this up too much. We have yeah, let's say we have I had to break that for a second to sort out my thought. So we have in this direction here we have time, and this is position, and this is value. So here is a specific position in a specific time. Okay, and we start here, and we have a lot of and we have all these positions here. So you could think about that this position here now is going like in that direction, and then we have time, which goes in that direction. So this picture here is that first slice here in time. So this is time 0, and here this is here is time 0, and here is 1 second, here is 2 seconds. So we have like the positions going like this. Okay, what I can do then is to say that, okay, this is the first time slice, so I'm taking this thing here, and then we have the wave over here, then, and I have all the values here, and then I like having shifted all the values a little bit in the next time slice. So if the top is here now, we may have shifted it so it becomes the bottom, and so this is bottom, top, bottom, top. So we may have shifted it around like this. So this is at time 0, and this is 1 second later. So we could think about this, as I said, like I'm tapping. Here is max, and here is minimum in this position here. So you could think about it like I'm tapping on the line all over the place, because this one here, and then I have another. I have to separate them a little bit. So I have a curve that goes like this, and then I have a curve that goes like this. And this is time, and this is position. So I've like just rotated this. Whoop. And here, if you look at that position here, oh, I do it badly. Like this. Oh yeah, it should be down here and up here. Down here and up here. I hope you can see what I'm doing here now. So this is position. This is like this thing here. So I have that curve here, this curve here, and then at another time I have this curve here, and that's opposite to the other one. And then I have the positions here, and if you look here, it's down at that position, same as this thing here, that particular position. I can go in and look at the values at that specific point, and then I get this shape or that shape or some else shape at that particular point. So I have at that particular point over time, I could represent it as a graph like this. But I can also, when I look at it in this way, I can also think about it as a wave that goes like this. So I first have this wave, and then I have this wave shifted. So if we, for whatever reason, call this peak here A, then this is A after a little bit, and then we have B here, and this is B after a little bit. That's a way to think about it. The way we think about it is that we have a specific position, and in that specific position the values change up and down, up and down, up and down. And here we have another position, and they change up and down, up and down. But there is another way to think about this as well. And if we have the curve like this, so we have the wave like that first, and then we have the wave like that. And here we have A as before, and here we have B as before. We can think about this as A being shifted. So here, A is here now. And this is B. So we could think, what I'm saying is, we could think about it as the wave is moving. And whether you want to think about it as something goes up and down, or if it's something that moves, it's a way to think about the values in points.